with me? Let's see how much you're taking away from this on the next page. They were like laughing hugely in second period at that. I don't know why, but they said, "Miss, quit tripping," and I didn't know. So here we go. What you need to know is that those 7 parent functions that I've given you in your foldable that you now have perfect analyses for are all fair game when it comes to transformation. I could ask you to transform any of those 7. In this first row of problems on our next page, we're dealing with absolute value. So that's the one parent function we're talking about. Look at your foldable or think in your brain and show me, what does absolute value look like? Awesome. Perfect. That's the
Thank you.
The absolute value looks like this, right? So what I want to do here in this first example is take that parent function, which looks like this, but the vertex here is centered where? 0, 0. And I want to try and perform the transformation that's given. All right? And we're going to use the same, I shouldn't have erased it, but the same mentality of, is the transformation happening inside my house or outside my house? And that's going to impact how I move. Okay? So when I look at this, the first thing I'm going to do is kind of like in a hyphenated way, put the original parent function on my grid. The absolute value that's centered at 0, 0. And then I'm going to come up to the equation and I'm going to start looking at what's different. In this case, that's a +4. And I'm going to have a conversation with myself that asks myself, is the +4 inside the absolute value bars or outside? Outside. So who am I hanging out with right now? My friends or my parents? Outside. Our friends. And when they tell us to add 4, we do what they want us to do, right? Like, it's cool to be agreeable with our friends. So if they say add 4, we're going to add 4. One thing I forgot to mention, anything that happens outside, this is an overarching theme with transformations. If the transformation exists outside, that will always deal with vertical behavior. Always. And if the transformation is showing up inside, no matter what it is, that's going to be a horizontal transformation. So you already told me that the +4 was outside, right? And we're hanging out with our friends outside. They say +4, I'm going to +4. And I'm also aligning that with vertical movement. So where do you think my absolute value is going to go? 4 up. That's it. So let's sketch that on here. 1, 2, 3, 4. Move our absolute value function 4 units up. Call it G, and we are done.
Wow.
It's okay? Now, second one. Same absolute value bars, but this time the +3 is where? On the inside. Inside. So this is like your mom, after a long day, saying, Gilberto, +3! You've got to add 3. And what are you going to do to find a teenager? Subtract 3. So instead of going forward to a +3, Gilberto's like, no, man, I'm not doing that. I'm going to go backwards to a -3. I'm going to put that same parent function on here. If you don't need this step and you don't need to see the original, then by all means don't do it. But you know me, I'm old and decrepit, and that helps me. So I'm going to take that, and because this is inside, I'm going to do the opposite. Instead of moving to +3, I'll go backwards to -3. What do you think? Maybe? I'd like for you to try C. There's a combo here. So think about what's showing up where, and then we'll talk about doing this in the opposite order in a minute.
Yeah.
You can probably
Like zoom in and go up to you.
Alright, careful. Tell me.
Copy you.
Did you really finish all of this? Well, he did. I just
2 miles. It was very sick. Yeah. After that,
So I believe in this last example, the -2's inside. So Lewis, what am I going to do? Careful.
To the left.
Let's dig down and get to the bottom of this. Remember, inside is automatically going to be horizontal. So your only options are left and right. And the 2 here is inside, so that's like my parents, they're Tony, right? Like your parents are like, subtract 2. And what are you going to do? Plus 2. Yes, exactly. So he's going to take the vertex that was at the origin and move it 2 units to the right. And then we go on to the next one, which is -1. And that's where? Outside. I'm having a good time with my friends, and they say, hey, Cece, subtract 1. And you're going to be like, yes, I will absolutely do that because I trust you. You're my friends. You would never lead me astray. -1 means I'll go down. Because on the outside, remember, that's vertical movement, down. So without drawing my original this time, here's my vertex, up, forward 2, down 1, and now I can piece together the rest. Oh, I should do it with a solid line. There's G of X. Okay? Right now, we're going to focus on translations only. Cece.
If we don't write G of X on top of our absolute value or even a margin one?
Nah.
Thanks.
I love that you're thinking about that, though, because you're learning more about this now and how I grade. Look at the bottom. So check these out. This time I'm giving you the graph. Instead of you creating the graph, here it is. And we want to try to describe what happened and write an equation. And the first thing I'm noticing is that these graphs are not absolute value like we had up above. Instead, what would we call these? Quadratic. Beautiful. So when I get to the part where I'm writing my equation, I don't want to see absolute value bars because this is not an absolute value function. Instead, I need to be seeing a little square or a power of 2 to represent the quadratic. All right, so in words, we can tell that some serious transformations have gone on here. Because the original quadratic, which we know, looks like this, centered at the origin, opening up. Our quadratic is not opening up, it's opening down. A math word for that.
Reflection.
Beautiful. Over what?
The x-axis.
Wow, y'all are so excited. Good job. Reflection over the x-axis. Additionally, that original parent function is centered at the origin. This is not centered at the origin. That vertex has been shifted. Not up and down at all, just sideways. This vertex has moved left or right, and how many?
Right.
Right, for sure. 2.5, right? 2.5 here. 2.5 units. So you can say translated if you're feeling fancy this Friday, or you can say shifted if you'd like. Translated right, 2.5 units. And generally,